Hello everyone. Today, before starting the new modulation technique, I am going to discuss a very important transform known as the Hilbert transform. Now, what is Hilbert transform? Any linear system can be represented as input, output and a transfer function. And y of t is given as x of t convolved with h of t. Now, Hilbert transform is represented as x cap of t. Now, this particular thing is said to be Hilbert transform when my h of t is equal to 1 by pi t. And the Fourier transform is for 1 by pi t is minus j signum of omega. Now, let me derive and show you how I got this. Now let us see. We know that Fourier transform of signum of t is 2 by j omega. Now using duality property. Now what is duality property? Suppose if I have a function f of t whose Fourier transform is f of omega. Now, in order to find Fourier transform of f of t, I will replace this by f of minus omega multiplied by 2 pi. Basically, Fourier transform of capital F of t is equal to 2 pi small f of minus omega. Now, using that, replace omega by t, 2 by jt, Fourier transform of this will be, let me write Fourier transform, will be 2 pi signum of, replace t with minus omega. Now, what is a signum function? Signum function is said to be 1 for greater than 0 and minus 1 for less than 0. Now, we can clearly see that signum function is an odd function. Odd function means f of t is equal to f of minus t is equal to minus of f of t. Same way, signum of minus omega is equal to minus signum of omega. So, I can write this as minus 2 pi signum of omega. 2 will get cancelled, and after rearranging the terms and bringing pi to the denominator and taking j here, I will get 1 by pi t is equal to minus j signum of omega. This is how I get the Fourier transform of 1 by pi t. Now, there are two important things to remember in Hilbert transform. What are they? Whenever your frequency is positive, in order to find the Hilbert transform, you introduce a phase of minus 90 degree. Let me explain this with two examples. For example, m of t is cos omega t and omega is greater than 0. M bar of t, that is nothing but Hilbert transform of m of t is equal to cos omega t and introduce a phase shift of minus 90. So, cos omega t minus 90, that is nothing but sin omega t. Same way, if m of t is sin omega t, m cap of t, that is Hilbert transform of sin omega t will be sin of omega t minus 90 degree, which is equal to minus cos omega t. And the other important thing to remember is, whenever my frequencies are negative, we will introduce a phase of plus 90 degree to find the Hilbert transform. It's opposite. If frequency is positive, introduce a phase of minus 90. If frequencies are negative, you introduce a phase of plus 90. That's how you find out Hilbert transform. In my next video, I will discuss SSB modulation, in which Hilbert transform plays a very important role. Till then, please share the video. Thank you.